Hello, welcome to ZIM Capture number 6. I'm inventor Dan Zen. ZIM at zimjs.com is an open source library to help you code interactive media on the HTML canvas using JavaScript and CreateJS. Let's go to the site now at zimjs.com. In the first 3 captures, we took a look at the basics of ZIM, the Learn area on the site, the News area on the site. And then in the 4th capture, we looked at the frame, which is a good place to start with a template to get coding. And we then looked at the docs in capture number 5 to see all of the functions and classes that you can use in ZIM. In this capture, we're going to take a look at ZIM Bits. So let's go to ZIM Bits now. It's a collection of small bits of code that will help you do interactive media, and they're all listed here. There's over 30 now, and I'm hoping to get to 64 within the year. Each bit you can see you can view it, you can see the code. You can also see a screen capture here. So this is the screen capture of all these, and sometimes this is an easier way to get back into one that you remember. Oh, I remember this one. Yeah, this is what I'm looking for. Okay, rather than the wording itself. What I'd like to do in this capture is take you through the format of a ZIM bit, and then we'll specifically look at drawing ZIM shapes. Okay, let's view the code, or sorry, not the code, let's view the actual bit. And this one isn't interactive, it's just showing the shapes. We can also view the code from here, so let's view the code, see what's in there. This is an HTML page, and we've got some navigation at the top. The HTML page has formatted code to show you, and the outside of all this code is what we went over in the frame capture when we talked about frame. Okay, so we won't do that again. But down here in the bits, each bit has a title, a summary, the steps for the bit, and then the actual code. If the code is more, then I will embed the steps right in the code as well as listing it up here. And then often there's extra information about the topic. That's the end of the format. Okay, so I'd like to now specifically look at making shapes. So let's go over this code, but rather than go over it here, I might want to make some changes to the code, so I'm going to go over the code in Atom. Here's that same code in Atom. And let's talk about ZIM Shapes. CreateJS itself has a shape class. And that shape class, you would make a new shape. So var shape equals a new shape. And then you would use the graphics property of that shape class to draw a rect or draw a circle. You would also have to set a fill and a line style. And that's several lines. Now it's good that they've split that up because you can also move to and line to, so draw any custom shapes. And that's great. But if you're making a rectangle or circle or triangle, it would be easier if it were just one line. So I wrapped the ZIM shape and put them in one line, such as a ZIM rectangle, ZIM circle, as we'll see. Another thing about CreateJS Shapes is they don't have a width and height property. You would have to set the bounds manually. And that's a good thing because you might not even be using the width and the height. So if you're making a shape that's complex, you don't want CreateJS to have to do the calculations on that, which takes processing power, when you might not even be using the width and height. So it is understandable that they've done that, but again, it's a little bit annoying to have to manually do that for basic shapes that you're making. So the ZIM shapes have the width and height set. Here are the steps. So let's take a look at this in action then. Here are the steps. You make a shape with the class. So here we are making a new circle with a radius of 50 and a fill color of that. There's also parameters for the strokes, but we didn't include those in this case, or we didn't use them. And we're assigning this circle object that we made to a variable called circle and adding it to the stage, which is the second step to add our shape to the stage. And then the third step is to position it and set various properties. So here we are positioning the circle at an X position of 200 and a Y position of 200. The rectangle is similar, except we've got the width and height of the rectangle there. In this case, both set to 80, so it looks like a square. And in this case as well, we're using ZIM center, so a ZIM center function to center that rectangle on the stage. That also adds it to the stage, so we don't need to do an add child. For that, it's built right into center. The triangle is similar as well, except we've got 3 lengths that we use to make the triangle, so that will be an equilateral triangle. We're adding it to the stage and we're positioning it. All right, now there's extra information as well. Just popping back here, the 4th step talks about registration points. And that means you've got to pay attention to where these things called registration points are, and they'll affect certain aspects of your shape. So let's go over registration points. It's a bit complex, and to help us go over it, as it says down here, we can use ZIM Outline to help us visualize what all these things mean. So I'm just going to copy the ZIM outlines for the circle, rectangle, and triangle and move them up here into our code and uncomment them like so. These will help visualize the registration point, the origin, and the bounding box. So let's see what that looks like. And we will open it up in a browser. And there we go. This is for editing purposes or building purposes. Sometimes this can be a bit confusing, so ZIM Outline helps in that manner. One thing to note, though, is ZIM Outline is a snapshot in time, in a sense. So if we were to move, after we do the outline, if we were to move the circle dot x is equal to 500, for instance, and save this, and we come back and refresh, earlier we outlined the circle and then we moved it. Note that the outline does not go with the circle. So if you animate something, the outline will not animate with it. Okay, and so it's just to sort of show you what's going on at any given time. All right, so we saved that. Now let's go back and talk about it. So a registration point is the circle. Well, let's start with bounding box. It's a bit easier. Bounding box goes around the outside. It represents the width and the height of the shape, okay, as expected, as you can see here. Now, because CreateJS allows you to manually set that bounding box, it doesn't always have to go specifically with the shape here. I could manually set it to go way off to the left, in which case our bounding box would be, a red box over here, and the shape would be here. So just watch for that. The other things here are the registration point is the circle. So a registration point is, if I'm going to position this square, it's almost like I pick it up by the registration point. And if I position it at 0, 0, for instance, if the x and y of the square were 0, 0, I would pick this square up by the registration point and put it at 0, 0. Same with the circle. If I set the circle to 0, 0, I would pick it up by its registration point and drop it at 0, 0, which means the circle would be partly off the stage. Whereas the rectangle here with its registration point top left corner would be on the stage right there in the corner. Is that clear? The other thing that a registration point does is if I were to scale the circle, it would scale around the registration point. So if I make this twice as big, indeed, it would just grow bigger, twice as big around like that. Whereas the rectangle wouldn't quite do that. It would grow bigger out to the right-hand side. So it would go twice as big this way and down like that. Okay, so the final thing is if you were to rotate this shape, then it rotates around the registration point. So this square would start rotating and it would look a little bit awkward. To rotate this square, it'd probably be better to center its registration point, and then you get it rotating around the center. So how do you move a registration point? Well, we could we can move the registration point by using, let's try it here. So in our circle, we will say circle dot reg x is equal to -100. So I'm going to move the registration point of the circle 100 over to the left. So the registration point of the circle moved to the left. I haven't explained this one yet. That's the origin. But it's moved over to the left from the origin 100. Okay, and yet we're still positioning the circle. It's still part of the circle. We're still picking up the circle at the registration point this time and putting it at 200, 200. So note that that did not move, but that caused the circle to move over that way. So it can be a little bit tricky. That's how you can move an origin. Now, the other thing, the X here, or sorry, that's how you can move the registration point. The X is the origin. And that means within the circle itself, this is 0, 0. So if we were to position anything inside the circle, have I mentioned, I'm not sure I mentioned yet, one of the things that it said in the extra bit is ZIM shapes are themselves containers. So the reason why a ZIM shape is a container is because of this thing called ZIM hotspots. Hotspots put things in things, so they need containers to work, and I wanted hotspots to be able to work with the ZIM shapes so that ZIM kind of all work together. Okay, that's a bit advanced, don't worry about it. But ZIM shapes are containers, so it turns out, another nice thing about that, of course, is that now I can put, if I wanted to, I could put something into this circle shape, or this ZIM shape. And let's try that. If we were to do that, this is position 0, 0 inside that container. So I'm going to pick up, or I'm going to take with code, I'll put the ZIM rectangle here into this circle. And when we do, the origin, it'd be like picking this up, the origin of this rectangle will be put right there. Sorry, not the origin. The registration point of this rectangle will be put right there. I think one of the things is origin starts with an O and I see a big circle. So sometimes I almost want to swap them. But on the other hand, it is this X right here is a symbol of a coordinate system. You know, that's 0, 0. So we can imagine a Cartesian coordinate with X going off this way and Y going off this way. So that symbol does make sense for the origin. It's just unfortunately the other one is an O. All right, let's put the rectangle then at the origin of the inside the circle. So we won't center the circle, or sorry, we won't center the rectangle. And we come to here and we say circle, oops, don't say that, circle dot add child rectangle. Okay, so we're going to take the rectangle and put it into the circle. And because we haven't positioned the rectangle at all, there's no X and Y, the default will be X and Y of 0, 0. Okay, we'll save that and refresh. Now the rectangle is placed at 0, 0 inside the circle. Let's try moving the rectangle over, say, 100 or 200, 300 maybe. Okay, so we take the rectangle, say rectangle.x is equal to 300. So now we've moved it over 300. This will move it over 300 from the origin within the circle. So now I've moved it over 300 pixels. Okay. Now what is being placed here? Is it which of these is moved 300 over? Is it the crosshairs or is it the registration point? It is indeed the registration point. So for instance, well, let's see that for sure. So what we'll do is we'll center the registration point in the square. So to do that, we can use ZIM center reg. So ZIM dot center reg and rectangle. So what that's doing is it's centering the registration point of the rectangle. You see how we set the registration point to -100? We could have said rectangle.regx is equal to rectangle.width divided by 2, and done the same thing for the height. But that's a bit of a pain in the neck. That would move the registration point to half the width. And same with the height, we'd have to do. But a short form for that is just center reg. So zim.centerReg rectangle. Let's see what happens now. We're going to center the registration point of the rectangle, so that would be right in here. But really, it's the registration point that's being positioned here. So what's going to happen is this whole rectangle will move up around that registration point. Refresh. Indeed it does. So now the position of the rectangle is 300 in x, 0 in y, from the origin of its parent, from the origin of the circle. Okay. The circle is positioned with, it's positioned at, was it 200, 200? But the registration point is -100 away from the origin, -100. All right, so those are some of the tricky bits about about registration points. And once again, if we were to scale this, now it would scale around the middle. Do you want to see that? See this scale around the middle? We'll go rectangle dot, well, I'll use ZIM scale. It's perfect. So we'd have to scale x and scale y. So ZIM scale is a short form for that. ZIM scale rectangle. Rectangle. Got it. So, ZIM scale rectangle, comma 2. So we'll make it twice as big. And refresh. Now this rectangle is twice as big, and it's scaled away from the origin. If we did not center the reg of the origin. So what I'm going to do is I won't center the reg of the origin. I won't scale. We'll refresh this. There it is. So if we scale it now with the registration point here, it will scale away from the registration point like that and like that. So let's scale. Save that, refresh. It scales out from the registration point. And if we were to rotate it, would rotate around, like keep this corner here and rotate the rest around. Okay, so those are some of the nuances of the registration point. We can use ZIM Outline. If you're having any problems with the registration point, use ZIM Outline. We saw the shapes being made, the circle, the rectangle, and the triangle. We saw the format of a ZIM bit. That's good. So I think we're there with this ZIM Capture. It's been a pleasure speaking with you. I'm inventor Dan Zen. Take a look at the other captures, and more captures are to come. Thank you. Ciao. Have a great day.